These are the video notes for linear inequalities. Looking at the first example, we are given a point and then asked if that point is part of a solution to the inequality x plus 3y is less than or equal to negative 12. There's two different ways that we can confirm if this is a solution. One way is to use substitution. What we will do is we're going to use the x value over and our y value of that point, substitute those in for x and y in the inequality, and see if we get a true statement. So the original inequality is x plus 3y is less than or equal to negative 12. Substituting an x of negative 4, we would have negative 4 plus, then we're substituting in positive 2 instead of 3 times y, is less than or equal to negative 12. This would be negative 4 plus 3 times 2 is 6 is less than or equal to negative 12. Bringing this over here, negative 12. Then we just have to check, is positive 2 less than or equal to negative 12? That's not true. This is false. Therefore, I'll put a big X next to it. Therefore, this is here's how you can verify that same solution by using a graph. Plus 3y is less than or equal to negative 12. I can graph this by rearranging it into slope-intercept form. So I want to get y all by itself. So I'll undo the positive x. So I'm going to subtract x from both sides. Y is less than or equal to negative x minus 12. Then to get y all by itself, I'm going to undo the multiplying by 3. So divide both sides by 3. Then I would have less than or equal to negative x divided by 3. That's like negative 1x divided by 3. So negative 1/3 x. Negative 12 divided by 3 is negative 4. So now I have this in slope-intercept form, and I'm going to start by graphing a line. So a slope of negative 1/3 and a y-intercept of negative 4. So y-intercept of negative 4, slope of negative 1/3. So down 1 to the right 3. Now I'm going to put this line in. And then I want y is less than or equal to. So that means I want everything on the line or below it. Less than or equal to. On or below the line. And so my solution area below this line, including the line itself. The point that we're trying to verify is negative 4, 2. So on this graph, an x of negative 4 and a y of 2. Sorry, it's a little crowded, but it's right there where I put that red dot. And as you can see, that point is not in my solution area. So that's how I know that this point is not a solution. Because my solution area is where I highlighted down here. This is the solution area. If the point was inside that solution area, then it would be a solution. Another example. On the right, we have the inequality 2x minus 5y is less than negative 10, and we're going to graph it. The way that we can graph it is we can rearrange it into slope-intercept form. So let's get y all by itself. And we have positive 2x. Let's undo the positive 2x first. So I'm going to subtract negative 2x from both sides. So I'm left with negative 5y is less than negative 2x minus 10. Then I want to undo y being multiplied by negative 5. So we're going to divide by negative 5. Do that to both sides. Then on the left, the negative 5's cancel out, so I'm just left with y. On the right, negative 2x divided by negative 5. The two negatives cancel out, so I'm just left with positive 2/5, and all of that's being multiplied with x. Negative 10 divided by negative 5. The negatives cancel out again, and 10 divided by 5 is 2, so plus 2. The sign, or the symbol. When you have an inequality, and when you divide by a negative number, we're dividing by a negative number right here, then you have to switch the symbol. Now I'm going to switch the symbol to a greater than. Okay, so don't forget this part here. We started with the less than, switched it to a greater than. And then this is my final inequality here. Y is greater than 2/5 x plus 2. So think of this as a line first. The slope is 2 over 5 and the y-intercept is 2. So y-intercept of 2, slope of 2/5. So I go up 2 to the right 5. 2, 3, 4, 5. Here. And I go the other way. 1, 2, 3, 4, 5. And then to make this line, I'm actually going to make it a dashed line. I'll tell you why in just a moment. Dashed line there. And it's greater than, so I want everything above the line. I draw in these arrows just to help me see which part of the line I need to shade. And then we're going to fill in our solution area, all of this. And the reason why we drew in a dashed line is because we have a greater than symbol instead of a greater than or equal to symbol. It's a dashed line. So here's my solution area. Any points inside this shaded area is a solution to the inequality. Anything on the line, not a solution. Anything below the line, not.